Okay, 6.8, graphing radical functions, note sheet. We're going to do some review from when we did the absolute value functions. Now, if you remember, in any mathematical symbol, whether it's parentheses, an exponent, here we have absolute value bars, whatever's inside that mathematical symbol, it moves left or right. Your parent function moves left or right. And it's opposite the sign here. So if I have an x minus 2, you would think it would move to the left 2, but it actually moves to the right 2. So if it's in the mathematical symbol, it's the opposite direction of the sign. Okay, if it's outside the mathematical symbol, in this case, it's outside here. By the way, this is called vertex form. If it's outside the mathematical symbol here, outside the absolute value bar symbols, it moves up or down. And it goes with the direction of the symbol. Oh, I think I zoomed in a little too much. Zoom out a little bit. Okay, moves up or down in the direction of the symbol, of the sign. Okay, so for instance, if I look at this equation, y equals the absolute value of x minus 2 minus 3. Inside my absolute value, I have to go opposite the sign, which would be to the right 2, so to the right 2, and then with the sign, so minus would be down 3. So down 3. And that's all when we did the absolute value functions a few weeks ago. Okay, similarly, um, the graph y equals the square root of x minus 2 minus 3 is shifted the same way because that minus 2 is underneath the mathematical symbol of the radical. And the minus 3, so that's going to go left or right. And in this case, it goes right because it's opposite the symbol. And then down 3. Okay. By the way, this is the parent function. I'm going to highlight my axis here because it's kind of hard to see. There's my x-axis, my y-axis. And this is the parent function of the square root of x. It starts at 0, 0, goes through the point 1, 1, and then 4, 2, because if I plug in 4 for x, the square root of x is 2. So 4, 2, 1, 1, and it goes on to infinity. Now, if I take that 0 point here, that 0, 0, and I go to the right 2 and down 3, there's the start of my new transformed graph. And again, 1, 1, 1, 2, 3, 4, 2. So it's almost easier to do this without a calculator than with a calculator, because by the time you start typing all the stuff in, it takes a while. All right, let's do the transformations of these radicals. Okay, inside my radical, I have a -1, so I'm going to go opposite, which is right 1. And then it's got a plus sign here, so it's going to go up 2. Now, number 2, we have a minus sign here, and just like we did when we did the absolute value function section, the minus sign in front tells us to reflect about the x-axis. Then inside the radical, opposite the sign, so it's not a right 3, it's a left 3, and then opposite with the sign for up or down. So I'm going to go down 4. So there's my transformation. Actually have 3 of them with that one. Now, fractions and whole numbers and being multiplied to our radicals here. So in this particular problem, we have a 5. So we could have a 5 or we can have a 1/5. Now we got to remember too, it's really hard to remember, and even with different functions, whole numbers and fractions do different things depending on what type of problem we have, what type of mathematical symbol. So what I'm going to do here is on a calculator, I want to see the difference between a fraction and a whole number. So I'm going to go to my y equals, I'm going to put in 5 square root, so second x squared, square root of x plus 4. Then I'm going to move this up so you see what I'm doing. And then I'm going to hit my arrow key to get myself out of that radical because I want the +3 out of the radical. So +3. I'm going to graph that. And it almost looks like it makes it, if I were to start at 0 here, it almost makes it look like this. So it's like taking my parent function here, and it's kind of like stretching it. So a whole number for the radical function, whole number stretches the function. I'm going to see what happens if I put, instead of 5, I'm going to do 1/5. And I'm going to graph them at the same time. So I'm going to put in my 1/5, 1 divided by 5, square root of x plus 4. I'm going to use this arrow key to get myself out of that radical symbol. Then a +3. I'm going to graph both of these and see what happens with the 1/5. Well, this time, it kind of squishes it, doesn't it, to my parent function? It kind of squishes it a little bit. So it actually compresses. Okay. It actually compresses my function. All right. Let's go on. Oh, we got to do the other transformation. So it's going to go opposite, so it stretches. Then it's going to go left 4, and then it's going to go up 3. So again, I've got 1, 2, 3 transformations. Okay. Now, I already kind of did the y equals square root of x function up here. And let's look at that parent function again. And it's called the parent function because there's no transformation, whether we're moving left or right or up or down. So It's called the parent function. This is called the parent function for the cube root. All right, so I'm going to get some numbers here. I have my x and my y, and because we're taking the square root, well, I'm going to take perfect squares. So 0 is and again, you always choose the x. So if I choose 0 for x, square root of 0 is 0. Okay. Now if I use 2 here, no, not going to use 2, it's not a perfect square. I'm going to use 1. Okay. Square root of 1 is 1. You know what? I was thinking of, well, maybe I'll try -1, but you can't take the square root of a negative without using complex numbers, and we're not going to use complex numbers or imaginary numbers. So we can't do negatives. So I get 1, 1, and my next perfect square, well, 2 times 2 is 4, and the square root of 4 is 2. So there's I'm going to use at least 3 points. So I get 0, 0. This is the parent function. 1, 1, and 4, 2. And if we want to go farther, let's see, 4, 9 would be the next perfect square. Square root of 9 is 3, 3 times 3. I don't really need it because I have 3 points to make a pretty good sketch here, but I'm going to use 9, 3 because it fits on my graph. So here's the parent function of the square root of x. So this is y equals the square root of x, parent function. Now, if I look at the domain, don't forget, is all my x values of the function. So here, my domain is going to start. Let's see, I have no x. I can't use negative numbers for my x. It starts at 0. It actually includes the number 0, so I'm going to use a bracket. And if I look at it here, it goes out to infinity for my x values. Okay, so it goes out to positive infinity. And since I can never reach that number infinity, I'm going to use a parenthesis because it doesn't include infinity. Now I'm going to look at the range. Okay, my range are the y values. So my range, and again, I have no negative numbers for my range. It starts at 0, includes that 0, and then this goes up to infinity, and it gradually goes up, up, up to this infinity on the y-axis. It goes up to positive infinity on the y-axis. And of course, we're using a parenthesis because it can never reach the point infinity. So that's the parent function y equals the square root of x. Now, let's look at y equals the cube root of x. This one you guys probably aren't too familiar with. So I'm going to, again, because it's an odd root, this time we can take the negative cube root of a negative number, because a negative times a negative times a negative equals a negative number. So we can take negatives. All right, so let's start out with the easiest one, 0, 0. Because if I choose, this is my x, my y, because if I choose 0 for x, the root of 0 is always 0, no matter which root we use. Now, let's look at the number 1, because 1 is a perfect cube. Cube root of 1, well, 1 times 1 times 1 is 1. So that means -1. Let's see, -1 times -1 is +1 times -1 is -1. Then I need the next perfect cube. So 2 times 2 times 2. And if you're not sure, you can always use your calculator. 2 raised to the 3 is 8. If I choose 2, I get 8. Same with negative 2. Now, be careful. Make sure you put negatives in parentheses whenever you raise it to a power. I get negative 8. So negative 2, negative 8. So let's graph this parent function. 0, 0, 1, 1, 1, 1, 2, 8, 2, 8. Those should be reversed. Yeah, because we're choosing the perfect cube for our x. And the cube root of 8 is 2. Same with this. This should be negative 8 and negative 2. Okay, so 8, 2. Negative 8, negative 2. Yeah, that looks much better. Okay, so I'm going to come up here through negative 2, negative 8, and it's going to go through, oh, I need negative 1, negative 1. Kind of do an S here and go that way. So that's my cube function. And again, we're going to look at the domain and range. So the domain, actually, this one's going to be a little easier. For my x values, it starts way out here in negative infinity, goes to positive infinity. So we're going to do negative infinity and positive infinity. Of course, infinities always gets parentheses. Now my range, think about this. This is kind of going up on an angle here, going up, down on an angle here. So again, it's going to use all the numbers. Negative infinity to positive infinity. So those are the parent functions, square root of x and cube root of x. Okay. Let's look at some more examples. First of all, the transformations here. This is a square root. So transformations here. Well, let's see. I'm going to go left 5, opposite that. So it's left 5. And then down 2. Down 2. Now you can do this one of two ways. You can put it in your calculator, get some good points, and sketch a graph. Or, again, this is a square root, so it's even kind of easier to do just on the graph. If you use your 0, 0, let's see, I'm going to go left 5, 1, 2, 3, 4, 5, and then down 2. So my new 0, 0 is at negative 5, negative 2. Then you can do your 1, 1, and then your 4, 2, and sketch your graph that way. Oops. There's my square root function without the calculator. Most of you are going to use a calculator. So let's go ahead and do that. So what you would do is put in the square root, second x squared, x plus 5 use your arrow key to get out of that radical, and then -2. I'm going to graph it. So I was a little off here. And then we're going to go to and get some what's called good points. We want some whole numbers so we can do this. So I'm going to go to my table. Second graph is my table. And definitely want to start at -5 because that's my starting point. If you notice, anything, all of those x values lower or fewer than -5, smaller, doesn't exist because then you're saying, hey, we're taking the square root of a negative number. We can't do that. So it has to start at -5, -2. So that would be a starting point. That would be a good point. -5, -2. Okay, another point. Well, another whole number here. I got -4, -1. -4, -1, and I need at least 3. Here's -1, 0. And I'm going to get one more. So I'm going to scroll down, get another, well, there's one, 4, 1. Get some whole numbers. So I got -5, 2, -4, 1, -1, 0, and 4, 1. So I did go a little high on that. Okay. Domain. X values. Well, it starts at, for my X value, smallest one, it starts at -5. -5 includes -5, so it gets a bracket. And then looking at the X values is going to go to positive infinity with a parenthesis because all infinities get parentheses. Look at the Y values. Now be careful here because my lowest number for the Y values, remember lowest goes first, is going to be this point here, which is -2 on the Y axis, includes -2. But then again, it's going to go up to infinity. Parentheses. Okay, number 2. This is a cube root, so it's going to look like a sideways S. Transformations. Let's do transformations first. Inside the mathematical symbol, or in this case, the radical, opposite the sign, so left 2. And then outside the mathematical symbol, up 1. Okay, this one I'm going to go ahead and do on the calculator. So many of us don't work with perfect cubes, and sometimes it's a little hard. Okay, now I got to remember what the perfect cube. I think you go to the math key, number, no, there it is, number 4, cube root. Hit enter, cube root of x plus 2. Use my arrow key to get out of that radical, plus 1. I'm going to graph it. And there's my sideways S with the transformations. Okay, I'm going to go, not a sideways, and I'm going to go to my table here and try to get some good, oh, there's a good one. Good points. So -10, -1. Let's see, what else? I've got some whole numbers down here. -3, 0, -2, 1, -1, 2. Let's see if there's one more. Oh, 6, 3. Okay, graph this. -10, -1, -3, 0, -2, 1, -1, 2, 6, 3. So here's my, actually, I think it's a flipped S. Here's my graph. And of course, in this course, I'm kind of lucky because for cube roots, it's always going to be domain, -infinity, +infinity, and range for cube roots, -infinity, +infinity. Okay, a couple of more examples. Transformations. This time we've got a minus sign here. So it's going to be reflect about the x-axis. Then we're going to have a left 1. And then up 3. We use our calculator. Y equals, I have a negative, and make sure you use the negative sign here and not the minus sign. Negative square root, second x squared, x plus 1. Use your arrow key to get out of that radical, plus 3. Graph it. See how it flipped? And it's not the x-axis, it's just reflects because we have transformations. If it was a parent function, it would reflect about the x-axis. Going to get some good points. Second graph. My first point is going to be -1, 3. Let's see, I got 0, 2. And 3, 1. And let's see if I can get another one here. Whoop. 8, 0. Okay. -1, 3, 0, 2, 3, 1, 8, 0. So here's my square root transform function. Domain starts here on my x value of -1, includes that -1, and it's going to go out to infinity, parenthesis. Then y-axis, y values. So the smallest number for my y is going to go, since this is going to go down, 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 -infinity. Okay, and then it's going to stop at when the y value here is 3 and includes that 0.3. And the last example here. Let's see, I have transformations. This time I don't have a reflection, but I have a whole number out in front. Now remember what that whole number was. It either stretched or compressed. And in this case, whole numbers for the radical symbol stretched. So it's going to stretch. Make it, remember, made it longer. Okay. Inside the radical symbol, I don't have any transformation. Okay, so it's not going to move left or right, but it is going to go down 4. So let's put that into our calculator. Y equals, clear this out, hit my math button, go down here to number 4, hit enter. Oop, I forgot to insert that 2. I need to put a 2 in there. 2 times the cube root of x. Hit that arrow to get out of the radical, minus 4. Going to graph it. See how it's going to stretch it, make it longer. Going to get some good points. Second graph. Let's see if we can. Oh, negative 8, 8. We'll start there. Negative 8, 8. Let's see, what else do I have? Negative 1, 6. Negative 6. Should be negative 8. Negative 6. 0, negative 4. Maybe 2 points the other way. 1, negative 2. 8, 0. Okay. Plot these. Negative 8, negative 8, negative 8, negative 8, negative 1, negative 6, 0, negative 4, 1, negative 2, and 8, 0. Here, it's my transform cube root function, kind of stretched it. And domain and range are easy for cube roots. Negative infinity, positive infinity with parentheses. Negative infinity, positive infinity with parentheses. And that does it for our radical functions, graphing radical functions. Are you ready for the practice work?